Alright, so let's look into the route policy. Route policy is a very important tool, especially if you are going to configure BGP. Alright, so a definition on the route policy. A route policy is used to filter route and set attribute for routes to change the path that network traffic passes through, which means that they have two actions here. First action is to do filter. Okay, once the filter match, I'm going to set an attribute. Right, let's look into the logic on how you can configure the route policy. First, we configure the policy using a command called route policy. This policy we are going to name it. Alright, so we have a route policy with a name. We are going to start the policy with a node number. Alright, we can start with number 10, then start with number 20, followed by 30. Alright, so for example, I have node 10 here. I have a condition. So this is a condition for the matching. I can have one condition or I can have two conditions. If I have two conditions, then the condition have to be matched. So which means that this is an AND operator. So both of these have to be matched for it to be a matching clause. If you only match the first one and not the second one, then it will move on to the second node. Alright, so if I have two matches, it's an AND operator. Now if it's matched, then you have an action. The action can be permit action or denying action. If it's a permit action, then I'm going to apply the condition. Alright, so it can be applying local preference, it can be applying cost, it can be applying next hop. Alright, you have a lot of action here. And then you pass the route policy. If the first policy is not matched, then you will move on to the second policy, and so on. Now, if you move to the last policy, assuming that this is a last policy, again, they are going to use the same process to do the matching and to do an applying. Okay. Now, if this is the last policy in your route policy, and there is none that match, then automatically you'll go into the denying. Let me show you how this route policy is being configured and their logic. I have here the router 1, and I'm going to show you the policy here. So first, if you want to see a policy, you do a display route policy. Okay, so this router is clean. So I'm going to create a policy with a policy name. So I'm going to call a policy called CY. Okay, then followed by the action. I'm going to do a permit with a node. I'm going to start with node 10. Next, I'm going to select the condition, and for us to configure the condition, we are going to use a command called if match. Alright, so that's my condition. If I match, for example, these are the matching condition. Assuming that I'm going to match an interface. If I'm going to match the interface, I can put another if match condition. So if I have two if match condition, then in this case it will be an AND condition. So which means that both of these conditions have to be matched for the condition to be true. So I'm going to match, let's say, the next hop, IP next hop. I'm going to use an ACL. Let's say I give them a basic ACL. So let me do a display this, so you can see that this node 10 have two matches, and both of them have to be matched for it to be true. Then I'm going to apply. Okay, so as you can see that these are the apply command. So assuming that I'm going to apply a cost of 20, there you go. So when I do a display this, you can see that I have a route policy with a name called CY. The action is permit and node number 10. And for me to match this, I need to have two conditions to be matches. If both conditions true, then I'm going to apply the cost. Else, I will go into the next policy. Alright, so assuming that I'm going to do the next policy, I'm going to quit from here. I'm going to retype route policy CY permit node 20. Do you see that? A new sequence of this list. So I'm going to match one more. So I'm going to mesh a ACL, let's say 2001. I'm going to apply, for example, a tag. Okay, so I'm going to give a tag value. Let's say I'm going to give them a tag of 1, 2, 3. Now, if let's say there is no other policy, as you can see that I have only two nodes here. Node number 10 is a permit statement. Node number 20 is a permit statement. If the policy doesn't match on 10 or 20, so assuming that the route that passed through doesn't match 10 or 20, as you can see that there is no other node here, then it will be automatically denied. Now, assuming that you do not want that to happen, then what should you do here is that you have to create another policy with a node 30. This time is a permit without any if match condition or any apply. So if I do a display route policy, you can see that I have three nodes. Node 10 with two matches for it to be true, and I'm going to apply the cost of 20. If the first condition not match, I'll move on to the second condition, which is node 20. I'm going to match ACL 2001, apply a tag of 1, 2, 3. If none of this match, then the rest will be default and pass through. Okay, so here is some of the logic that I show you on how the route policy work. Let us examine one topology, and I'm going to introduce you a route policy and the uses of the route policy under these circumstances. So assuming that now I have four routers, R1, R2, R3, and R4. Now R1 attached to the network 10, and R1 import this route to OSPF. And when you import, it will become the external route. Alright, as an OSPF OASE. Okay. Now when you import this route as an OSASE, the preference that I have will be 150. Now assuming that this route sent to R3 and R3 import the OSPF into RSIS. Now when RSIS receive it, which is in R4, R4 will advertise this to R2. And assuming that R2 also import from RSIS to OSPF, then R2 will send this to R1, and R1 now receive both of the route, one from the original 10 network, another one which is 10.0.0/24 from R2. Okay, so now the problem here is assuming that now R2 received the route one from RSIS, which is 15 priority, another one from 150. Alright, but this one is external. So in RSIS, my preference will be 15, and for OSPF external, it will be 150. What will happen here is R2, we're going to use R2, R4, okay, R3, and finally R1 to the destination. Now this is not the best path. So this is one of the problem that we are facing. Alright, so we are facing suboptimum route. Now another issue that we are facing here is the routing loop. Now assuming that R1 connection to the 10 network failed. Okay, so this is failed. Now remember that R3 already sent this information to R4, R4 sent to R2, R2 sent back to R1. Now when R1 detected that this failed, R1 will have a next hop sent to R2. Okay, so this will happen. R2 is going to go to 10 network. Alright, when it want to go to the 10 network, it will send it to R4. R4 will send it to R3. Now R3 detected that R1 also sent this OASE to me, so I'm going to send to R1, and R1 in return will send to R2. And what happened here is we have a loop here. Okay, so I'm going to show you how you can solve this issue by using route policy. Alright, on the next lab. If you want to control the route advertisement, we are going to use a filter policy. All right, so in this slide, we have one example here. R4 receive this network, and R4 are advertising this 4 route to R3. This 4 route, we have a condition. The condition is R3 are only allowed to send 2 of this route to R1 and 2 of this route to R2. Now, given such a condition, how you can achieve it? Now, one way for us to achieve it is to use a filter policy together with route policy. Alright, so you have to combine both these features together to achieve such a solution. So we are going to look into this solution later on in our lab. Alright, so let's look into filter policy. Alright, so here this slide explains that we can use filter policy to filter outbound filtering and inbound filtering. Now, assuming that now we are running on OSPF. Alright, and this OSPF we have a ABR. Now, the main function of ABR here is to translate the type 1 and type 2 to a type 3 LSA from one area to another area. So here we have area 0 and here we have area 1, for example. Now, we can implement the filter policy in our ABR. Alright, so once we configure the filter policy over here, those routes that met our policy will be filtered. So we are filtering the routing information. Okay, so here routing information is filtered. But remember, when you configure filter policy in OSPF or even ISIS, which is a link state information is not filtered. Remember, only routing information filter. And when we configure our filter policy, we configure in OSPF in ABR, alright, where we are going to filter type 3, and ASBR where we want to filter type 5 and type 7. Now, we also can implement filtering for inbound. So again, link state protocol do not add route into routing table. So basically, when you configure the filter policy, those information that you filter will not go to the LSA, but the link state information will still allow to pass through. Now, assuming that now you have another scenario. So here I have RIP going into a ASBR router that's running OSPF. Now, when you import route from RIP into OSPF, OSPF is going to advertise this as an external ASE. Okay, so that will be on the type 5. Now, when you do this, we are going to filter based on the route, and when we do a filter, it's always as an outbound filter. Okay, so this will always be export when you do the filter. Alright, so it will be always an export outgoing. So we import so that we can filter it to be export. Now, we can use the route policy to set attribute. In this topology, I have two AS number, AS200 and AS100. Now, AS200 advertise the route to both R2 and R3. Okay, so R2 set a policy. So we have a route policy over here. Alright, this route policy select if I'm going to match this network. Alright, so I'm going to apply a local preference of 300. Now, once you have a route policy, let's say I call it an XXX, I'm going to apply under the BGP, under the router 2. Under the BGP 100, I'm going to say that peer 1.1.1 route policy XXX export. So this route policy that match the 10 network, we're going to send this to R1. Alright, and when R1 receive it, what R1 will do? So based on R1 will have two next hop. The two next hop here that's going to 10.0.0.0. The first one will be in R2 and the second next hop will be in R3. Now the R2 have a local preference of 300, okay, and in R3 the local preference is 200. So end of the day, R1 will send the next hop to R2 to go out, right? So we can use a route policy to set attribute, and this is commonly done when you configure BGP. Now here we have a policy-based route. Now policy-based route is different compared to route policy. So how does PBR work? All right, let's look into the theory on the PBR. PBR is a mechanism that select route based on user-defined policy. The user-defined policy can be based on ACL. It can be based on the source. All right. Now this is definitely different compared to the route policy, because route policy is based on destination. All right. So this is a destination base. This is a user-defined base. Okay. So PBR changed the packet forwarding path based on attributes such as the source address, packet size, or link quality packet. So which means that, as I mentioned, I can determine the next hop based on the source address. If your source address, assuming that 1.1, you are going to send to the hop of 10.1.1.1. If you are a source of 2.2, I'm going to use a default route, for example. All right, that is based on the routing table. All right, so here we have the policy-based route. Okay, so it can be based on the source, it can be based on the size, or it can even be based on the link quality of the packet. Now there are three types of policy-based route. First, we have a local PBR. It means that the packet must be generated locally. So assuming that I have three routers here, and this is the router who actually generate the packet. If I have a packet that is generated, then I can use a PBR local. All right. But if let's say this is not a local generate PBR, so assuming that you are going to configure local PBR here, where the packet is passing through, then this local PBR will not take effect. And if you want to configure the PBR under such circumstances, then you should use a interface PBR instead of local PBR. So you have to use the interface PBR. Now, if you have a certain requirement and you need to get the license for this, we call this as a smart PBR. Now, smart PBR is not based on the source or the packet size, but it's actually based on the link quality. And the only drawback here is that you have to pay extra for this function for it to work.